You are all welcome. We have started the course today, percentage composition. Uh, in the percentage composition, we want to solve series of questions today that explain what exactly we understand by percentage composition. So, in first and foremost, what we need to understand in percentage composition is the definitions. How does it even go likes and what is the meaning? You said the mass, come, the mass of one mole of a substance is the sum of the masses of the mole. So, of the component element in the formula of substances of the mole of the component element in the formula of each element formula of substances. Sorry, it is a formula of substances. Formula of substances. So this is the definitions of the percentage composition. So now we would like to have so many examples that speak directly to the percentage composition. It said the mass of one mole of substances is the sum of the mass of the mole of the component element in the formula substance. So what exactly are they really talking about? Let's have an example. We have example said find the percentage composition of the individual components, individual components elements in calcium triazocarbonates. Carbonates 4. So now solution. What is even the name? So it will give you a formula. That is what we used to deal with in chemistry. What is the formula for calcium triazocarbonate 4? This is calcium triazocarbonate 4. So this is the formula for the calcium triazocarbonate 4. Now, in the calcium carbonate 4, how do you now get it done to get the molar mass? So percentage decomposition of each. Now, if you have this COCO3, implies that 1 mole of Ca, it comprises of 1 mole of Ca, comma, 1 mole of carbon and 3 mole of oxygen atom. So this is exactly what you want to calculate that will give you the percentage compositions of Ce of each of the one. Now, naturally, before we start doing that, we firstly do something we call molar mass. Mass CaCO3, and the calcium is 40. You know, I've said it earlier to 1 times 40 plus C is 12. 1 times 12 plus O3 is 16. 16 times 3. So by the time you add everything together, we have 100 gram. So enter. So you can send some messages which are we able to share fit out of. So let me continue from this place. Now, after we have able to get this a formula for percentage composition, we have a formula for percentage composition. The formula is mass of element over molar mass times 100. So that is the formula for percentage composition. So if now we now be doing it one by one. Now let's firstly find the one of mass of calcium. Mass of calcium, which is equal to 40 gram. So the one of 40 gram is we're able to get the molar mass of COCA3. Let me clean this place. Now, the CaCO3, the CaCO3 molar mass is 100 gram per mole. So the percentage compositions we do like this for calcium will be, and the calcium is 40. For calcium, which is 40 gram, will be 40 over 100 to multiply 100. That is just the meaning. So it will multiply 100 and it will give you, this will cancel this, it will not give you 40%. So, we are considering CaCO3. So percentage composition for calcium, and the calcium is 12 gram. So percent will be 12 over 100 times 100. This will cancel to give you 12%. So for the percentage compositions of O3, which is 16 times 3, and the 16 times 3 is 48 gram. So it will be 48 gram over 100 to multiply. So this will cancel this to give you 48%. So that is how we calculate percentage composition for that. And we have so many questions I want to we're able to discuss much better. I will take your time to write what I've able to wrote there. And if I have another good example, so please, you help us to send message to know exactly where you fall to from what we have been doing since. Okay. So we have another example. I'm coming. So percentage composition of the following. One, two, we have the other one is 3. KClO3. So this is in calculating this, let's be doing it one by one. We have for the H2 SO4, it will be 2 times 1 plus 32 plus 16 times 4. It will give you 2 plus 32 plus 64 is equal to 98 gram. That is for the H2 SO4. Now, we have 27 times 2 plus 16 times 3 which is equal to 54 plus 48 which is equal to 102 gram. Do I clear them? So, for another one is for the KClO3 to give you the KCl, the potassium is 39 plus chlorine, that's 1 molecule of chlorine, 35.5. Now plus 16 times 3. So everything will give you 122.8. gram. So we can be able to see from this angle how does the value works. So that is just, we call this the molar mass of all this. Now, in calculating percentage composition for the H2SO4, for the H2XO4, it gives us 98 gram. So in calculating for the H2, it will be 2 times 1. So for the percentage compositions of hydrogen, it will be 2 over 98 times 100. So it was so small. So by using our calculator, we finally get the value. I'm coming. So that is the percentage. I will now calculate once for the X. To give you this. For the percentage of X, we have 32 over 98 to multiply 100. So for the percentage of O4 will be we have 64 over 98 times 100. So that is, we are only using 30 minutes every day like this. For anybody that have interest, should send me a message if you're a passerby for the more of these values of what you have been doing. So thanks for attending the class today. I don't see any of the message as a response. This surely makes me to brings an end to this live. So thanks for watching, taking your time. So let me clean the board for the next one, which I want to solve. So there's another thing we call molar mass. So I'm setting the board better. Sorry. So I've been able to explain but now I want to explain more about molar mass, because I realize that many of what I've been doing since, you might not get it. But molar mass, it is if you are to calculate molar mass of a substances, for example, the question says you calculate molar mass of KClO3. In the first 20 elements, you must understand the atomic mass and molar mass. So the molar mass is important to know before you go to the empirical formulas and other. Any compound given to you, this is a compound. So you must understand that calcium, it is 39. You must understand that chlorine, it is 35.5. You must understand that oxygen is 16. So in calculating the molar mass, there's some certain thing that it is important to put in place after you are able to know. But remember, for the entry of the exam, it must be also be given. It is important to know that it is always given. So the K, you'll be adding it 1 mole of calcium plus 1 mole of chlorine plus 1 mole of O3. So that is just how you are going to do it. And what is the 1 mole of calcium? It is 39 plus 1 mole of chlorine, 35.5, plus 1 mole of O3, and it's 16 times 3, which will give you, so in total it will be 122.5 grams.